another lesson. In this lesson, we'll discuss numerical on thin lens formula and linear magnification. Now, before we start our lesson, let us revise your thin lens formula and your linear magnification. Now, according to thin lens formula states that 1 by V. This V is your image distance. So, if this is your convex lens, and this is your image, then the this distance is known as your image distance. So similarly for your concave lens, suppose this is your concave lens, this is the image form, and this is the distance from the center of the lens, then this is your image distance. So 1 upon image distance minus 1 upon u. U is your object distance. Suppose for convex lens, this is your image, and this distance is your image distance, which is denoted by small u. Similarly, for your concave lens, if this is your image, then the distance from the center of the lens is known as your image distance, denoted by small u. Fine. So this is your object distance. Okay, this u stands for your object distance. This u stands for your object distance. So 1 by v minus 1 by u equals to 1 upon f, where f is the focal length. This distance, okay, this distance is your focal length for your convex lens. This distance is the focal length for your concave lens. Now, one more thing to note is that for your convex lens, the focal length is positive, since it is measured in the direction of the incident light, which is from left to right. And the focal length for your concave lens is negative, since it is measured in the opposite direction. Fine. It is measured from right to left, but our incident light flows from left to right. Fine. So since it is in opposite direction, therefore your focal length for your concave lens is negative. Fine. Now we can move to our questions. Now coming to our numerical, a needle placed 45 centimeter from a lens forms an image on a screen placed 90 centimeter on the other side of the lens. Identify the type of the lens, determine its focal length. What is the size of the image if the size of the needle is 5 centimeter? So in our question, okay, they have first asked you to identify the lens and determine the focal length. Okay, for this what you will do is first you will determine the focal length. After you have determined the focal length, then you can identify which kind of lens. Let's go back. See, if we know if our focal length is negative, then what kind of lens we will have? Concave lens. And if our focal length is positive, what kind of lens we will have? Convex lens. Fine. Now, after you have determined the focal length and identify the type of the lens, next what you have to find? You have to find the size of the image. Fine. You have to find the size of the image. Now let's look at the hint given in this question. Now here a needle is placed 45 centimeter from a lens, forms an image on the screen placed at 90 centimeter on the other side of the lens. Okay, so here your needle acts as your object distance. This object is placed at a distance of how much? 45 centimeter from the lens. Fine. So this is placed in front of lens. Fine. So the question states that suppose, let us assume a lens. Fine. Now this can be your convex or this can be your concave lens. Fine. Now what you'll do is consider this line as your principal axis. Fine. So let us say your object is placed at 45 centimeter in front of the lens. Okay. Fine. According to the question, the object is placed 45 centimeter in front of the lens. Fine. If the object is placed in front of the lens, in that case, what happens? The object distance. This is your object distance. Okay. This object distance will be positive or negative. This object distance will be negative. Why? Because it is placed in front of the lens. That means the object distance is measured in the opposite direction. Opposite direction to the direction of the incident light. This is the direction of the incident light. Fine. Now, since your object distance is measured in the opposite direction, in that case, I'll write down solution. So, according to the first hint, your object distance is given as 45 centimeter. Fine. And it is minus. Now, why minus? Because it is measured in the opposite direction. Now, the next thing is that the image is placed 90 centimeter on the other side of the lens. Fine. If the image is placed on the 90 centimeter of the other side of the lens, then so the image will be formed 90 centimeter away from the lens. Okay, so this is your image distance. Fine. Now look, the image distance V is measured in the direction of the incident line. In that case, your image distance will be positive or negative? It will be positive. So I'll write down your V equals to 90 centimeter. Fine, according to the question. Okay, let me highlight this point here also. It is placed 90 centimeter. Fine. Now, so you know the object distance, you know your object distance, you know the image distance. Now, I can use the formula of thin lens formula to determine the focal length. So, using thin lens formula, fine. According to thin lens formula, 1 by V minus 1 by U equals to 1 by F. Now, your image distance is given as 1 by 90 centimeter. Your object distance is given as minus 45 centimeter. Fine. So I'll write 1 by F here. Now, see, this negative sign and this negative sign can get cancelled. Okay, so if I cancel them, what happens? They will become plus. Fine. So let me just erase this negative sign. So here you will have plus 45 centimeter. Fine. Now I have to add 90 and 45. Okay, for this you can take the LCM. If I take the common LCM, this will be 90. Here will be 1, here will be 2 equals to 1 by F. 1 plus 2 is how much? 3. Fine. So I'll write 3 upon 90. Fine. And I can cancel them out. 3 times 30 equals to 90. Fine. So I can write here 1 by 30. Fine. Now I can do the cross multiplication. Right. So after cross multiplication, I can write the focal length F as 30 centimeter. Fine. So this 30 centimeter is the focal length. Fine. So in our case, what kind of focal length we got? Positive or negative? We got a positive focal length. Okay. So if it's a positive focal length, then what kind of lens you have? You have a convex lens. Fine. This convex lens. Okay. Now note, if it has a positive focal length, okay, if it has positive focal length, what do you see? The image formed in this case is converging. So we also call this lens as your converging lens. Fine. Now since it has a positive focal length and the image is formed by the converging beams of light. Okay, converging means they are moving towards a particular point. Okay, so this is a converging lens. Fine. So your convex lens is also a converging lens. So don't get confused. Similarly, look at your concave lens. In this case, what you notice is that the image or the light after refraction, it bends away. It moves away. Or I'll say it diverges. Diverges from which point? This point. Fine. Diverges from this point F. Fine. So in this case, your focal length is negative. So if the light diverges, fine, and the focal length is negative, then what kind of lens you'll call this one? We can call this one as diverging lens. Fine. So this is your diverging lens. For now, look, in our question, we got a positive focal length. If it is a positive focal length, what kind of lens we got? Convex lens, or we can also say what kind of lens we got? Converging lens. Fine. So I can write if the focal length is plus 30 centimeter, then in our case, it will be a converging lens. Fine. Fine. So this is how it will be. You have a convex lens. This convex lens has a positive focal length. Okay, can you see this length? Light after refraction passes through the focus. The point from where it passes or it crosses the principal axis, this point, okay, and the distance between the center of this lens, this is your focal length. Fine. So your focal length is positive. Fine. So this is how it will look. Okay. Let me make this figure a little bit bigger. Okay, just a minute. Huh? Fine. Now, after determining its focal length, which is how much? 30 centimeter. and we have identified which kind of lens it is, which is a converging lens, that is a convex lens. Fine. Next, what we have to find the size of the image. Fine. Now, suppose this is the size of the object h1. Fine. Now, according to the question, it is given the size of the needle is how much? 5 centimeter. Fine. So this is how much? 5 centimeter. Okay. And this is h2. This is the size of the image. We need to find h2. Fine. For that, what you will do is, again, let's first write down the important points which they have given in the question. Okay. They have given the size of the object h1 is how much? 5 centimeter. If the height of the object is 5 centimeter, then using the formula of your linear magnification. Okay. The linear magnification formula states m equals to the size of the image h2 upon the size of the object h1. Fine. Apart from this, it also states that it is also equals to the object distance, sorry, the image distance v upon the object distance u. Fine. From here, let us find out the m first. So, what is your object distance? Sorry, what is your image distance? 90 centimeter. And what is your object distance? Minus 45 centimeter. Fine. So, using this details, my magnification m equals to my image distance 90 centimeter upon my object distance minus 45 centimeter. Fine. Now I can cancel this two term. 45 times 2 equals to 90. Fine. 45 times 2 equals to 90. So how much I'll have? See, this negative sign, okay, it will go to the numerator. So I'll have minus 2. Fine. This is minus 2. Now, if you know the magnification, now using this formula m equals to h2 upon h1, I can find the size of the image. Fine. So we know m equals to h2 upon h1. You know the magnification is how much? Minus 2. How much is h1? h1 is 5 centimeter. Fine. Now I can cross multiply this one. If it multiplies with minus 2, in that case h2 equals to 5 times 2 is 10, and there is a negative sign, so it will be minus 10 centimeter. Clear? So now look, it is minus 10. What does this minus sign denotes? It denotes that my image form should be in the downward direction and perpendicular to the principal axis. Downward direction and perpendicular to the principal axis. Fine. And one more thing, the image, okay, the image form, okay, the size of the image form is how much? 10 centimeter. Whereas how much is the size of the object? 5 centimeter. That means my image formed is double the size of the object. In that case, what kind of image will it be formed? Okay, if the question have asked what kind of image of what kind of magnification it is, okay, in that case you can also answer one more point. See, the h2 is greater than h1. if H2 is greater than H1, in that case, I'll just write down a small note here. Note. Okay, if H2 is greater than H1, then what kind of image will be formed? The image form will be magnified. Fine. Now next, if in any case, okay, suppose your object, okay, H1 is greater than H2. Fine. In such case, where the size of the object is greater than the size of the image, in that case, what kind of image will be formed? It will be diminished. Fine. Now, let's consider one more case. What happens in the case where the image and the object are of same size? That means H1 and H2 should be equal. Fine. In such cases where H1 is equals to H2, in that case it will be same size. Okay, neither it is magnified, neither it is diminished. Fine. So you can take this note. Fine. Okay. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So again, thank you.